Okay, now the moment of truth. Will I be able to talk? So I apologize for the hoarseness. You'll probably find me coughing a whole pile of times. So be patient. If the voice completely gives out, then we will too. All right. But unfortunately, I mean, I would just say, okay, I'm bothered with this, but unfortunately, if you don't cover this, then you're behind a lecture and you'll have problems with the labs, and it snowballs into this big pile of problems. So I'll try to get through everything that's here. If I do end up having to stop early, sorry, I'll have to leave it as a video for you to watch over the weekend. I don't want to do that, but that's how we'll handle it. All right, so variable scope and parameters, more stuff to do with functions. Okay, although in theory this was probably a little bit covered in infs 1101, I know that students when they reach 1201 usually have a pretty limited scope on variable scope, so I found it kind of important to actually include this. Okay, so here we go. What exactly is this? Okay, so here's the sections of the textbook, the usual thing. All right, so the word scope has to do with where a variable can be accessed. Okay, so in other words, when you define a variable inside a function, who else has access to that variable? Okay, and you know some of the answer to this. If you define a variable outside of the function, who has access to it? And those can be kind of surprising. All right, so I think the best thing to do, even though it's here on the next page, is we'll do a small example first, then we can talk about the slides. Okay, because no, not yet. Next page. Okay, here we go. So I've got myself a function. Sorry, a rather complex looking function. I was tired of doing simple things like adding two numbers together and so on. So I thought, okay, what could I do? And thinking, okay, I'm doing a whole bunch of stuff in PowerPoint. Here is a typical function that you might have in a program like PowerPoint. And that is, if you have a bunch of text to write, how wide is the box? Okay, because obviously the more text you write, the wider it's going to be. Okay, so that's exactly what this is. Given a piece of text, so that's a string, given the size of the font, because you make the font bigger, the box has to become bigger. And of course, given the name of the font, so Calibri, Times Roman, Courier, these are very typical things. Obviously, the box is going to be a different size. So I figured, okay, I'm only going to have two fonts in my system. I know a real system has a lot of fonts, but we don't have the data structures for it yet. So let's just suppose we have Calibri, which is the standard one that almost everybody ends up using on Word. And there's also Courier, which looks like programming language. I use it all the time for that. All right, so here's what it does. If you say that the font size is less than 0, all right, that's some kind of an issue. Okay, so all that I do is I return a message saying font size must be positive. Okay, that's kind of my error case. That was just to remind you that if you ever hit a return, it shuts down the function, doesn't go any further. Yeah, you're too loud for being too close for being this voice today, okay? All right, so here we go. So it shuts down the function, doesn't go any further, it just returns. So the stuff that happens down here never actually occurs, all right? All right, so the next thing it does is it brings the font, it makes it lowercase, because sometimes people type Courier with a capital C or Times New Roman or whatever. So I just make it lowercase so that I can do a comparison. And basically I said, okay, if it's Courier, then the character width is 0.6. Otherwise it's 0.5. Different fonts have different sizes. And if it isn't any of these, it returns an unsupported font type. And finally, to figure out the width, I took the length of the string multiplied by the font size multiplied by the character width, and it gave me a number. Is it realistic? No, it's just a number. Okay, this is all that I wanted was just a number. I'll give you an example of using it. Okay, so first of all, if I run the program right now, we knew this from last time, what happens? Absolutely nothing. Because it's just, I'm defining what the function's going to do whenever it gets used, but nobody's actually using it. All right, so let's use the function. Okay, so you use the function. We get rid of that Docker menu. Here we go. To use the function, you call calculate text width. And I know there's some extra things in here, which we haven't talked about, that it is going to be talked about today. All right, to use the function, okay, I call it like this. That's how you call it, set of parentheses. What happens if I type this? Well, surprisingly, absolutely nothing, because you're not actually calling it. It's not an error, because you can actually take a function and store it inside a variable. It's a very, very strange thing. We don't cover it here, but you can do this. It's got some advantages. Okay, without the parentheses, nothing happens. With the parentheses, that actually causes it to happen. However, we know from last class, how many parameters do I need to pass in here? Yeah, 3, because there's a text, there's a font size, and a font type. I need to provide these 3 things. And of course, it has to be in that order. Okay, well, that was the rules yesterday. All right, so the first thing up is some text. So here we go, hello world, typical thing. All right, the next up is the font size. Okay, if the font size is 40 points, okay, it's going to tell me the width. And we'll use Calibri, not Calibri that way. Calibri this way as the string, and of course if I go ahead and I run it, absolutely nothing happens because, well, what did we expect? There's absolutely not a single print statement in this entire program. So I am calling the function is giving me a result, it's just I'm not doing anything with it. Yeah, so we need to obviously print it. So either I can put a print statement here, or just as a temporary thing, I'm just going to call it R. I don't know what else to call it right now. I suppose a better name might be width. We'll use W for width. I know we're not supposed to use lower or single letter variables, but sometimes when you're doing testing, it's okay. All right, and of course what we're going to do is we're going to print W, and it comes back and it says it's going to be 220 pixels wide. All right, and not a big surprise if you make this 50, it becomes a bigger box. Okay, that was the whole idea. It's obviously not the real calculation, it's just something I wanted to make up. All right, so there we go, pretty good. Inside the function on line 13, I calculated a variable called total width. Okay, and then I returned total width. Why did I do that? Well, so that I could just round it later. Didn't mean that I had to do it, but I've got this variable called total width. So what I would like to do is down here after printing W, I'd like to print total width. And that should be, of course, the same number without being rounded. Now, for this one, it's probably not going to make a big deal because I'm probably getting some very, very nice rounded font. So let's pick something like this that'll give me a decimal number, right? Because that total width is the same value that gets sent back. So therefore, it should be the same number, but it won't have the rounding. So instead of being some number, it's going to have decimal blah, 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 blah. Okay, so let's clear the screen, and we'll run this. And do we see the same number twice? One rounded for W, and then the other one for full. And if your guess is yes, you've guessed wrong. Okay, so here's the deal with this one. This is a classic case of variable scope. The variable called total width is defined inside the function. Okay, it's inside the function calculate text width. You can use it all you want inside calculate text width. Well, after you've defined it. You can't use it, say, on line number 5 because, well, we haven't defined it yet, but we could add whatever extra lines we want right here using total width. It'll work perfectly fine. But this is a local variable, and what happens is after a function is finished, all local variables get thrown out. Okay, they get deleted. They're no longer there. So things like total width, that's going to show up as some kind of a problem. It says there's no variable called total width. Okay, because it's not here. The same thing is true with font size and character width and text. None of those variables exist out in the main program. Okay, so all of the stuff that's not inside a function, I always refer to this as the main program. Sometimes I have to put quotes around it because some people, when they program in Python, you may find this online, they may actually make a function called main, and then they will call the function called main. I just tend not to do it here because it's just one extra thing that I have to cover. Okay, but when I talk about the main code, I'm talking about the code that's outside of all of the functions. Okay, so if we try this with anything else like character width, yeah, it's also not going to work. Okay, so here we go, char width. And of course, we know that that's defined on line number 8 or 10, as long as I've got something, but no, it's not defined out here. Now, to make things a little bit more interesting and challenging, let's go back to what I had a second ago, total width, okay? Did I spell it wrong? Okay, no, okay. If they're saying that, I thought maybe I said it. It's easy to do. All right, here we go. Total width is equal to 400. All right, so now I've got a different situation altogether. You see, the variable called total width on line 17 that's no longer a local variable inside a function.
That's in the main.
That's out in the main area. Okay, it's out in the main code. And that means that that's completely allowable and accessible in the main area. Okay, that's exactly what it is. So obviously, when I hit line 20 and try to print this, am I going to be able to print it? And the answer is yes, I am. But maybe the trickier question is, what value is it? We know from the last time we ran it that the function is returning 288.8. So we know that there's some decimal stuff afterwards. So the question becomes, is it going to be 288.8 blah, 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 or something else? Okay, well, as usual, let's give it a try and see what happens. All right, so this is what happens. What we ended up with was, inside the function, this was calculated as 288 point something. We don't even know the rest of it. But at the end of the function, that variable went away. What about the variable out here called total width? Yeah, well, that's still there. Because remember, when you call a function, wherever you're calling it from, that part of the program basically goes into suspended animation, doesn't do anything until the function returns. And then you get back your same old values again. Oh, but yet it's going to be a little bit more complicated. So in other words, when I calculated total width is equal to here being 288, it actually had no impact on that variable called total width on line 17 because, well, I defined it inside the function. All right, so there you go. So there's some scoping rules. Okay, so any variables defined inside a function are not accessible outside of the function. Okay, that's a pretty simple rule. There's really not too much else we have to deal with. Okay, so let's take a look. With that, yeah.
It's recommended not to use the same name outside that.
Yeah, it's probably a good idea not to because it'll lead to less confusion.
Yeah.
Okay, because sometimes people may look at this and go, wait a minute, shouldn't, sorry, if I'm up here and I try using the variable called total width, is it not defined or is it 400? It leads to confusion and it's a good idea not to, but it's going to happen.
Okay.
Oh, why is it going to happen? Okay, you're going to see me use a bunch of really short variable names when you get into looping over elements in a list. Like sometimes if I have a list of students, I may use the variable s as a student. For every s in the list, do something. Okay, we will have to do this because otherwise our program becomes really, really big. And of course, guess what? You might have many cases where you're using the variable called s. Okay, so it can happen. You should probably try to avoid it, but sometimes it just ends up happening. Okay, so that one's pretty easy. Okay, and that looks after the second bullet point. First bullet point we already talked about. Scope has to do with where a variable can be accessed. Variables created inside a function and the parameters, so the parameters are treated exactly the same way. They're called local variables. Anything that you do to them only affects while you're inside the function. As soon as you leave the function, all of those local variables and parameters are completely gone. You can't use them. On the other hand, you see there's another bullet point in here, which is something a little bit different. Okay, so off we go, and let me see, I believe I have an example, so I would rather use the example. Okay, we got another function. Okay, I think what I'll do is I will trash this function. I'll bring up another function. All right, and again, it's the same idea. It had to do with some documents just because I happened to be, I had a PowerPoint open at the time and I thought, hey, this would be cool. All right, so this one is estimate the number of lines that we have in a document or in a piece of text given a font size. Okay, so obviously more text, more lines. Okay, bigger font, less lines. Less lines? Well, okay, bigger font. I guess it probably doesn't have too much to do with the actual size because usually a text box that has 20 lines of text, okay, it has to do with the font size. To make the font bigger, it's obviously going to take more lines because it's going to fill up the space faster. All right, so I came up with a formula. All right, is the formula correct? No, it's just a made-up formula. Before we look at anything that's going on inside here, I just want to call the function first. Okay, so ignore, even though you'll see something that's kind of weird we haven't talked about yet, we will get there. Let's just pretend we don't see it, and let's look at the function call. All right, so the number of lines, I'm going to say estimate the line count of the following piece of text. Okay, it's going to be a lot of text, so I'm going to use a triple quote so it goes across multiple lines, and I'm going to put 15 here as a font size. Now, what I need is some text to put in here. Give me a second while I find some text that I can copy and paste. Okay, how about this? How about the missed assessment policy? Okay, so this is for a different course. Copy and... Okay, we can't see the entire thing, but that's okay. Is this allowed when I'm breaking this thing up across multiple lines? Okay, there you go. Is this allowed or is this going to be an issue? This is okay. The reason why it's okay is because of the quotation mark that I used. I used a triple quote. Okay, so I used 3 single quotes. That's a triple quote. That is a single string, and what it means a multi-line string. Okay, so there's a whole bunch of things. I've broken it up just to see how it's just so we can see all the characters, but in a single line it would do the same thing. All right, and of course, just like we've done last time, yeah, we're going to print lines. All right, and it's going to tell me how many lines, and it complains saying cars per is not defined. Whoops. Oh, cars per. Oh, let me get back to my slide. Cars per. Okay, something got cut. It's actually cars per line. Okay, yeah, sorry about that. It got cut here. It got cut on the slide as well. I'll try to remember to fix that. There you go. So its estimate on 15 point fonts is this going to take 70 lines. Okay, again, it's not realistic. I just needed some numbers. And of course, if I reduce the size of the font, okay, here we go. We'll make it an 8-point font, and you run it. It takes less lines. Okay, that's all I'm trying to get here. Now, let's start to look and see what we've got, because there's some stuff which is very, very different. Okay, and that is, there's one magic word. It's showing up in orange, and we haven't seen it yet. The word global. All right, the word global on line number 8 says, there is a variable out in the main called page width, and I want you to use it. Okay, so for some reason, whoever wrote this piece of code has decided that they want to access a variable that's out there somewhere. I don't even know where it is. That's actually one of the reasons why you don't want to use it, but there's a variable called page width. So when you try to calculate page width, it's going to go and find it. So what's the page width? Well, it's 100. Okay, let me remove, now, here's a bit of a problem. Let me remove this, okay? So what do you think? What do you think the behavior of this should be? Yeah, it should be some kind of an error saying that, hey, you're not allowed to do this because there's a variable here called page width, and I don't see it anywhere, and there was nothing marked as global. Unfortunately, it continues to work. I think it's a flaw in the world of Python. Okay, all right. So, yeah, it turns out it's kind of optional. Okay, I'm going to come up with some rules on it. All right. If you're using global variables, they should always be listed as global. So you make it very clear to the person writing the program, we're talking about the variable that's out there. Okay. So, I'm going to pick a much simpler example. So it looks like it's optional. Great. Again, I don't like it. That should have been a failure to say it's no good. Now, I've got a couple things I'd like to try, however. Okay, so let's find out if I were to take this and I were to paste it down here, does my program still work? All right, so let's check this one, and the answer is yes. It doesn't matter even where you put it. It says when you try to access page width, here's what Python does. It looks around the function and says, is there a variable called page width? And when it doesn't find it, it says, oh, let's go out in the global scope, out in the main, and see if there's a variable somewhere called page width. So that's what it does. Having the word global makes it much more clear about where it is, because you can imagine the problems that this could happen. I mean, especially if you use a very simple variable like x. I mean, if you had a really big program and somebody has a variable called x out in the global scope and you start using it, and worse, you start modifying it, things get really, really, really bad. Okay, so it turns out that there's a word called global. It's supposed to mean it's out there somewhere. Unfortunately, if you leave it out, it seems to be automatically assumed. I don't like it, but this is what we deal with. Yes?
If you put the page width equal 100 under the calling of the function, will it work?
Under the calling of the function. Hey, that's a cool idea. All right, so there was a request to take this out of here and put it here after I've called the function. Well, okay. What do you think the value of page width is? Yeah, that's it. It sounds to me like this is not going to work. Okay, but it might end up failing for a slightly different reason what you expected. Okay, the good news is it fails with the reason what you expected. Yeah, it's not defined because nobody's actually set the value to be something yet. So here's a bit of a downside to using variables that come from the outside is if somebody outside forgets to initialize them before calling the function, your function crashes. So whose fault is that? Is that the person who called the function or the person who wrote the function? Yeah, it's the blame on the person who called the function, but you see the problem happened on line number 8, and the developer who got this error will come back and knocking on your door saying, hey, you messed up, you forgot to define this. It turns in, so this is the thing that I always say in the world of programming. You either do things right. If you don't do it right, make sure the blame goes to somebody else. So just don't let it come back to you, and it'll be perfectly fine. It's another good reason not to use these things called globals because it does depend on somebody else actually setting them in advance. Now, what I'd like to do, I want to really simplify this quite a bit to give another reason about why maybe we don't want to use variables, or these things called globals, and I'd like to build my own square root function. Okay, it's not going to be a very good square root function, by the way. Here's what I'm going to do. In fact, I'll call it my square root. All right, and here's what I'm going to do. Normally, when you want a square root function, you provide a value that somebody's going to compute. So I'm going to call it x. It's a generic value, a real number. That's perfectly fine. Here's what I'm going to do to calculate square root. I'm going to take x and I'm going to divide it by 2. I know it's not real, but it's all right. I just need something. All right, so here we go. We're now going to print this, and we're going to say my sqrt of 10. All right, so what is the square root of 10? 5. Okay, good. I know it's not real, but maybe we have to do something else. Sometimes if I have a bit more time, I have some loops set up to show Newton's method, so you can see this over in calculus. Sorry, I didn't have time today because of some other work. All right, so that's fine. That's a parameter going in. I'm getting back a response. Instead of passing this a parameter, let's make it a global variable. All right, I'm just going to make it a global variable. So if you wanted to calculate the square root of a value, what do you need to do? Well, you need to set x equal to whatever number it is, and then you call this. Right? You set it just before you call, then you call the function. Kind of weird, isn't it? Yeah. Everybody, as soon as you write this one, people go, wait, no, that's silly. Okay, let's make it even worse. Let's go through all the values for I in range 1 to 10. 1 to 10. Okay, so I'll go to 11. And here's what I want to do. I want to print I, and I want to print the square root of I. You see, what I have to do to use my function is I have to make sure I set a variable called x equal to I. And now it'll work. But there's one extra step you have to set up before you call the function. Kind of weird. I think once you see this, you go, no, I think I prefer just putting the I inside here. Yeah, that's actually the entire point. However, why did people sometimes do this? Okay, there's always there's a few really good reasons. Let's take a look. I've got them in the slides. Okay, go back. Where is it? All right, so variables defined outside the function are called global variables. They can be accessed and modified by any function. Cool, so one variable and all the functions have access to the variable. Really convenient. The values are retained when calling functions. Okay, we'll have to come up with a reason for that. Okay, so I'll make something. All right, so here we go. We've got the examples that I've just done. All right, now here's a couple of things. Oh, modifying. Oh, we haven't done this yet. Okay, we've only been using the value of a function, of a global variable. Let's start modifying it. Okay, let's have a reason first. Okay, and once again, we're back in, and did I include? Okay, it's a slightly different example. So let me go back to my usual slide stuff. Okay, let's make a function. Now, we're not actually going to print the slides. Okay, we're not actually going to print it. Here's what we're going to do is, okay, what sound does a printer make? Zzz, okay, zzz, there you go. Good. So that's our printer printing. All right, and just to make it very, very clear, I'm going to say exactly which slide number we are printing. So here we go, slide num. All right, so here we go, and we're going to say print slide, and it asks for slide 45. Bang, there you go, this is 45. And since we're here, I'm going to call print slide 46, and we're going to print slide 50. All right, so there you go. There's 3 slides being printed out. Obviously, in reality, what you have to do is you have to open up a connection to the printer, send all the data. I mean, it's cool. We could do it, and you'd be able to do it just after you're finished this course. We still need dictionaries, we still need lists to be able to do it, but by the end of this, we could actually do this. Okay, so we've got these 3 slides going out. I've been very nice. I didn't use a global variable for the slide number because I think it makes a lot more sense to say, hey, print slide 46. Not set a variable called slide number equal to 46 and call print slide.
Yeah.
That is kind of acting a bit weird. This will be considerably nicer. All right, so now let's have a problem. All right, here we go. How many times was print slide called in my program? 3 times. All right, I would like to have the program record this fact for me automatically. And this is going to be a reason why you might need global variables. All right, so the first thing up is you might say, well, there's no problem. What I could do is I could put up a loop and I could print, and just increment it each time. But I want to do this a little bit different. You see, I want to be able to keep track of what's going on inside this function. So what I'm going to have is I'm going to have a variable called total slides printed. No. If I said is equal to 0, and at the very end, I'm going to print total slides printed. You see, what I want to do is I want to print the 3 slides, and then I want to see the number 3. Okay? Now, obviously, if I do something like this, is this going to work? And the answer is no. This blows up because total slides printed is, what's it called? Global or local? It's a local variable inside print slide. So at the end of the function, it's gone. All right, here's what I'm going to do. I'm going to make it global. How do you make something global? You stick the word global, and you say that total slides printed is a global variable. And I'm not going to set it equal to 0, but I'm going to add 1 to it. Okay? It's a global variable. Global variables retain their values after functions are called. All that I need to do before I start my entire operation is I just have to say total slides printed is equal to 0. I call the function 3 times, and here's what happens. The global variable calls total slides. After the first time, it goes up to 1, then it goes up to 2, then it goes up to 3. And the result is, fine, we get the three results, and that magic variable called total slides printed goes up exactly the number that we want. And yeah, I can copy and paste if you want to duplicate this one. There you go. And of course, now it'll run 4 once I get my finger on the right spot. All right, so yeah, kind of automatic. Yes?
Sir, I have 2 questions.
Sure.
Can you explain global again with tracing?
Global again with tracing. Yes, I can. Tracing, I will need some tracing paper. Here we go. Here's some tracing paper. Okay, I like to use Excel for this type of stuff because it's just a grid. Okay, when it comes to tracing, and we don't do a whole lot of tracing in this course, by the way, other than I usually don't get people to write out these sheets, that is. All right, so normally what we do in tracing is we always have a column called a line number to let us know what line number we're working on. Then we have one column for each variable. All right, so what variables do I have? I have a variable called slide num, I can see that one. It's a parameter. It's a variable. Oh, and slide num is a local variable to print slide. Okay. There's another variable called total slides. Okay, I'll be a little bit lazy. You know, total slides printed. All right. So here we go. The very first line that occurs is line number 9. Okay, very good. So line number 9. The value of slide num on line number 9. Yeah, it's undefined. It doesn't have anything. Okay, I'm not even going to say it's none. I'm not going to say anything. It's just, it doesn't exist. Because if we tried to print it right now, it'll say no, because it's a local variable. We're not even inside the function. It only exists while we're in the function. Total slides, on the other hand, is equal to 0. All right. After line number 9 comes line number 10. All right, line number 10. Line number 10, okay, slide num doesn't exist yet because we haven't started the function. This is simply the first part to say I'm about to start the function. What's the value of total slides? Still 0. All right, here we go. And after line number 10, well, we jump into the function. That becomes line number 3. All right, line number 3, what's the value of slide num? Yeah, 45. That was the number that was just passed in a few seconds ago. What's the value of total slides? Still 0. It is defined. It's a global variable. Okay, it's always there. Things that are defined in the global scope are always there. Okay, they're always there. So I still leave them. All right, so line number 4. Well, line number 4, it doesn't really cause anything to happen. It's just a placeholder to say this is a global variable. Line number 5 happens. The value of slide number is still 45. That hasn't been changed. But what happens to total slides? Oh, and by the way, this is the global slides. So this is the one. What does it turn into? On line number 5. Yeah, it becomes 1. Okay, and there's only 1. All right, now, yeah, I got a couple of questions. Yeah. Global is saying there is a variable out there somewhere outside of this function that I want you to access. Exactly as this. So this variable right here, this is a global variable. You see, if you were to try and do this, okay, and again, I know that Python kind of allows it, it would look at this, if it was a decent language, it would look at total slides printed plus 1, it'll say, but there's no variable called total slides plus 1. It's only because somebody defined it out here as a global. So the word global is supposed to say, hey, there is something called this out here. Okay, that's what it means. Now, I'm going to remove this in a few seconds because I'm going to give you a real big shock, but once we get there. Okay, all right, so far, all right. After line, now where'd my tracing paper go? Here we go. After line number 5 comes line number 6. Okay, it doesn't do anything, print something. Okay, but the value of slide num is still 45. The value of total slides is still 1. All right, after line number 6 comes line number, all right, some people say it goes back to line number 10. I will do that. This is like, I'm going to call it 10 plus to say it's just after the function was called. Okay, and of course, what's the value of slide num once I get back out to the main function? Doesn't exist because it's a local variable, so all the local variables go away. So you can't even put a number here. And what's the value of total slides? Still 1 because there's only 1. Okay, all right, line number 11 is the next thing that pops up. All right, line number 11, num slides doesn't exist yet. This still has the value of 1. After line number 11, well, we make a jump again into line number 3. At this point, slide num becomes 46. And the process continues, and the number of total slides is still 1. Okay, get the idea? So this global variable called total slides printed, it's a variable that exists, and it always exists. You have access to it even when you're inside the function. Any value that's set by the function continues to exist, and it doesn't go away, unlike a local variable. Local variables all vanish at the end. Okay, so there we go. There's a trace. Now, I need to start doing some extra things because there's a couple of weird things. They'd say, wait a minute, this is already weird enough. Okay, here's a really, really good comment about this, by the way. You should actually never use global variables. So problem solved. Don't use them, no issues. Unfortunately, what's going to happen is there could be like some tracing questions that show up and say, hey, what's the output of this? And we want to find out, do you know that that's a local variable? Do you know that this is a global variable? All right, here's the one sort of surprising thing. All right, here's what I'm going to do. Okay, so this is like some of those horrible Kahoot questions I end up giving, but here we go. Sorry, print slide. Oh yeah, this is one of these weird functions that doesn't return anything. Yeah, sometimes they happen. All right, this is not a trick question. What gets displayed when I run this program? 45, okay, very good. Okay. Okay. Now we'll definitely see what happens. Okay? All right, so remember, global means there's a variable outside and I want you to use it. That's what it means. So the program starts on line 10. Total slides is 100. Okay, I call the function on line 11. I go inside. On line number 5, I set total slides equal to 45. Yeah, the global variable called total slides. I then print it. Okay, on line number 6, what gets printed? 45, very good. I return from the function, and then on line number 12, I print total slides. What gets printed? 45, okay, so good. You're seeing 45 twice. That is exactly what it should do. All right, now, remember we kind of looked at this earlier and we said, well, it turns out it's just kind of convenient. No, this is maybe a little bit different. All right, because if it was convenient, we'd probably see exactly the same thing. But instead, when you run this, you don't see the same thing. All right, so here's the one anomaly you have to be prepared for because almost for sure I'm going to put a trace question on midterm and or final involving something like this because these are the things that catch people off guard. And by the way, you should never be using global variables. You won't get caught off guard. Unfortunately, sometimes some other people write functions. You have to figure out what they've done. All right, so we think it's going to work like this. All right, okay, first of all, the very first line that happens is this line. That's easy, okay? All right, next line that happens is this line. All right, what's the value of total slides right now? 100, very good. We make the jump up to here. We do line 3. Total slides is still 100. This one right here supposedly sets it to be 45. So we would then, on our next line right here, this would print the value, 45, very good. And I return, I come back down to here, and I do this one right here, and I print it, and I should see 45, but instead I see 100. Okay, why? All right, here's the way how this works. When you want to change a variable, okay, if you want to change a variable inside a function, this is the way Python was designed, it's considered a local variable, unless you said explicitly it's a global. Okay, so without the word global, that's considered a local variable when you try to change it. If you try to read from it, it lets you do it. But if you try to change it, you need to have the word global if you really want to change it. Otherwise, it becomes a local variable, and at the end of the function, the local variable called total slides disappears and back down here. And at this point right here, if you're saying, wait a minute, does this mean that there are two variables both with the same name? Yeah, there is. You have access to the local one, not the global one.
So line 11 prints the one and the main.
It prints the global one, yeah. Okay, that's the one weird place. Now, as I said, the best thing in life is just to avoid them. Okay, because this type of theft can really get you, really cause you some trouble. Unfortunately, there are certain styles of program where you need them. And the types of programs sometimes that I end up writing, I also need them. The way how everything on the web works, it turns out you actually need quite a few global variables. There's ways how you can mitigate it, but it has to do with the programming style. Here, you're used to the idea that you start a program and basically do one line at a time. When you're dealing with graphical user interfaces, what you're doing is you're setting up a button that says when the user clicks this button, make them do something. And unfortunately, You can't always just follow the information around because there's really no main. Luckily, we don't have it in this course, okay? But we do have to be aware of that little quirk right here, that if you try to modify a variable without global, you're modifying the local one. If you try to, here we go, sorry. If you try to read it, it works perfectly fine. So when this runs, the first print statement is right here. What gets printed? 100, okay? Even though I haven't declared it as global, we still have access to it. Okay, so you have to know the difference between that. Again, not because I want you to write code like this, but because you sometimes end up in a situation where somebody else is giving you some code and you have to fix it. Okay, so that's what it is. So if somebody gives you code with global variables, I know what I should have done. Okay, give me a second. Okay, maybe I'll add this to the slides for next time. Okay. Yeah, there we go. That will work perfectly fine. I'll add this. Okay, if somebody gives you a function with some global variables, yeah, they slap them. Okay. All right, here we go. So all I need to do is put some actual speech that has something to do with global variables, local variables. Okay, I'll add it, but sorry, it won't be for this semester. Let me get back to my slides. Where did I go? Okay. Okay, I think I might survive this. We're going pretty good. All right, so global variables. Let's see what I've written here. All right, modifying a global variable happens to be called a side effect. Okay, so side effect. Okay, I have to come up with something. I forgot this word was here. All right, so tell me what printing the slide should do. That's not a trick question. It should print the slide, right? Should it do anything else? Yeah, I mean, come on. If the function is called print slide, that's what it does.
Yeah.
Okay, and it shouldn't really be doing anything else. All right, take a look at this. Oh, sorry. I probably wasn't going to run that anyway, but that's all right. Here we go. Page width. They made it global. Why? Well, because when you send something to the printer, you need to know what size the page is.
Yeah.
Okay? Let's call it page size. That's even better. All right, so you know that there's A3 and A4 and so on. All right, so here's what we're going to do. Slide number on page size. All right, so we want to print slide 30. Here's what we need to do. We need to say page size is equal to, okay, we want it big. We'll use one of those A3, and then we'll print the slide. So there you go. Page 30 gets printed on A3 paper. Okay, pretty simple. We'll talk about why the person did this in a second. We don't have this problem so much in Python. Okay, well, first of all, you know, functions are never just 2 lines. They tend to be pretty big. Maybe it's 30, 40 lines. I don't know. They had a bunch of if statements in here, and somehow or another, page size is equal to A4. Okay, here we go. This is now my little program. Okay, I've got a global variable in the function called page size. So when we're in there, we're talking about the global one, and it's guaranteed. I've marked it global just to make sure it's very, very clear that it is global, because I don't want a surprise. And what's happened is, well, the printer warms up and it actually spits out the page. Actually, it should also say gem because it usually ends up happening. All right, and then for some reason the programmer, whoops, accidentally changed the global variable called A4. Why? They made a mistake. It happens, by the way. Okay, again, yeah, fine, you can slap them, but that's a bit of an issue. So yes, it does print, but as a side effect of printing, for some reason, the page size has changed. Does that make sense? If I print the page, should the page size change? And I think the answer is no. I mean, normally you set the page size, say, please print this on A4.
Yeah.
And it should print on A4, and it shouldn't say, oh, now it's A3.
Yeah.
All right? No. It's not called print the slide and then change the size. This is called print slide. Okay? So, in other words, yeah, it's not a good design. That effect of having something changed is called a side effect. You call a function, and somewhere out of nowhere, a variable changes you didn't know. that's kind of a little bit dangerous. It removes all of this talk that we would have learned in INFS 1101 about functional decomposition. Decompose problems into smaller and smaller pieces. So if I call a function to do something and something changes, that's not good. Like for example, if I call a function to calculate your GPA and it changes your GPA, is that good? No, I don't think so. The whole idea is please calculate, not change the GPA. Changing the GPA, maybe it would be okay to change it. Well, if it's called change, it's fine, but not other things. That's called a side effect. Okay, so here we go. So normally you want to avoid side effects. I mean, like we hear side effects from medicine. Nobody ever talks about the good side effects of medicine. Usually it's because they're more worried about the bad ones. All right, so to access, if you want to use it, you really should use the global keyword to remind you that you're doing it. And of course, if you're using it, you don't need it. When modifying, you absolutely need it. But it says here in the next bullet point, global should be avoided. Yeah, if the print function needs the size of the page, pass it as a parameter. Much safer. Because, watch this. Let's pass it as a page size, not as this global variable. There we go. This type of thing happens. I'm going to pass in page size as the second parameter. All right, so here we go. Page size is set to A3. Okay, good. I make a call to print page. Zip, it comes up here, and zip, out comes the page on the correct page size, which is passed in here as the second parameter. And then the programmer accidentally changed, again, how does it accidentally happen? You copy and paste code. And that's usually what happens. Somebody copied and pasted a bunch of code. They got it from ChatGPT. It's going to happen. And ChatGPT didn't know that you shouldn't change the page here because the programmer didn't type enough of a prompt. This is a problem about LLMs. If you don't give it the full things, it will get ready for it to do anything. It accidentally changed it. But my question becomes is when you come back to here, what does it show for the size? Is it A3 or A4?
A3.
Yeah, it will actually say that it's A3. The reason why it says this is an A3 is because this variable right here is a local variable, also known as a parameter. Parameters are just like local variables. So if you modify a local variable, it has no impact on the rest of the program. Cool. Isolation, that's what you're looking for. Okay, that's entirely what you're looking for. All right, so globals can make large programs really difficult to maintain because when you call a function, the programmer might modify the global variable unexpectedly. Okay, true story. The system that I used to work on when I worked in the previous place, there was a function, get ready for this, it was called S. Okay, it was really, the function was called S.
S?
Yeah, just S, the letter S.
Oh.
Okay, what was it? It was to step through the code. Okay, it was provided by the system. It was to make it so you could type S really quickly on the terminal to step. All right, perfectly fine, except somebody in the company made a global variable called S. Do you know how hard it is to find a single variable called S in a piece of code that's about 150,000 lines of code? Yeah, you'll never find it. I found it. I mean, I didn't spend 5 years looking for it, but I found it 5 years later. It was like, oh, there it is. It has something to do with cryptography. And what it was, actually, I had this question in the lab the other day. Somebody said, well, wait a minute. Yeah, but I used N. It was in the formula for the number of months. And I said, no, write it out. And that's literally what it was. Somebody had a formula and it said that S is equal to this. So they defined a variable called S. And they made it global. And it worked perfectly fine until somebody came along, me, trying to step through the code. I mean, I had to work around that for several years. I had some really weird things to have to deal with. All right, so it could be an indication we're almost done. All right, so why do programmers actually use global variables? All right, you need it sometimes to maintain state. So if I really wanted to record how many pages were printed, I have no choice. So it can be necessary. Sometimes it can be helpful. And really the biggest reason is laziness. Why? Well, you don't have to pass in parameters. You don't pass in parameters, that's excellent. For a quick little one-off thing that you're doing just for fun, yeah, it's fine. But if you're doing real code, it's pass things in as parameters. It's going to be much safer. You will not see me ever ask you to write a function with a global variable here. I may give you one and ask you to trace it to make sure you understand what happens if you use a global variable, but I usually would never ask you to do this. All right, so here we go, maintaining state. It's a slightly bigger problem. It's pretty close. What I'm doing here is I've got this variable called count readings, and it's simply changing it, and every time that I call it, of course, the number just keeps getting bigger and bigger. It's a couple of global variables. Just so I don't run out of time, let me go on to the next one. Okay, these are default parameters. Okay, sorry, we need to go back to a previous example. Okay, because these are kind of fun. All right, so here's what we're going to do. We'll get back the width, that was the box width. We're going to call calculate text width. All right, we're going to pass in some text. Okay, doesn't really matter. All right, I'll pass in a font size. Pass in a font size of 30, and I'll pass in a font type as Calibri. Sorry, it's quotes, Calibri. All right, and of course, important, we're going to print the width afterwards. So here we go. Okay, the width of the text box is 315 pixels. Okay, excellent. We were back to this earlier. Now, I'd like to do something. Okay, what do you think? Well, from our discussion the other day, it should be no, right? Because I'm supposed to have 3 parameters get passed in for the 3 arguments.
Yeah.
All right, however, if I let the, and of course if we run it, well, there should be like some kind of a crash saying, no, it's undefined or it's got the value of none. Actually, it works. How? All right, well, right here, you'll see that it said font size is equal to 12.
Okay.
What this is saying, it says, if the person calling doesn't provide a font size,
So it's on that.
assume that its value is 12.
Okay.
Okay? It's a shortcut. And we all like shortcuts because that's the standard size. That's what the size that most people end up using, because when you start up Word, it starts as 12 point. And in Word, it happens to start up as 12 point Calibri. So I can leave that one off as well. Anything that has an equal sign, you get to leave out. It's actually really, really cool. You've been using this, you just don't know about it. Okay, take a look at this. Help, print. This will give me all the information about print. Take a look at what print does. Okay, it's different. It is very, very different. It's actually pretty tough to write. But what it takes, as soon as I find my characters, okay, here we go. It takes args. Okay, you know that's not a pirate. Args. Okay, those are arguments. The star in front says that it takes a whole bunch of arguments. Okay, we don't cover that in this course. We use it all the time, but we don't cover it for writing functions. All right, that's fine. And then take a look at this. There's something called sep. Well, I showed you that in the first week. Sep is the thing that goes between the characters, and if you don't specify it, what is it? It's a space. It's right there. That's what it's used for. Oh, and also, there's something called end, and if you don't specify it, what is it? It's a new line character. That's why the whole thing works. These are default parameters. Very, very useful for some things. Okay? All right, so let me see what else we've got coming, because there can be more things. Really? Nobody's going to ask? Let me see. Did I put it in? No. Okay. All right. I'm gonna put this in. All right. So let me get back to this. I'm gonna put a couple print statements just so we know for sure what's going on. Font size, comma, font type, just to show you what they are. Okay. So it's 12 in Calibri. Okay. All right. If you say 30. What's the value of the font size inside the function? 30. And what's the value font type? Calibri, because the second one defaults. And of course, if you do courier, all right, well, single quote, there you go. It's going to obviously take both. So you have the option of passing in all 3, but you also have the option of passing in the first one, or the first and second, or the first, second, and third. Okay, how about the first and the third, but not the second? Yeah, the first and the third, but not the second. You can do it, but it requires a little bit of a weird syntax. All right, so in other words, I don't want to specify this.
Okay.
but I want to specify the font size. If I run this right now, this whole thing goes really, really bad because the font size is Calibri and the font type is, the font size is Courier because that's what I passed in, and the final one is Calibri. So this is what's causing the issue. But the question becomes is, well, can I just pass in the font type? And the answer is yes, I can. We've seen the format before. It's like this: font type is equal to. Okay, so what I'm doing is I'm saying, please change this one, but leave all the others as default. This becomes really, really important. I know I'm pretty sure everybody in this course eventually ends up taking a course called Data Science, DSAI 2201. And in that course, you're going to be using Python. You're going to be using a lot of libraries, and a lot of those libraries have a lot of parameters. So when you say, please analyze this data, they might pass in 10 or 20 or 30 parameters. And most of the time, you don't care what they are. You just want the regular default ones. So what you're doing is you're constantly doing this type of thing. The X values are this, the Y values are this, the model is equal to this, everything else accepted. So I'm just preparing you for this one. All right, got the next one. Okay, and we're almost there. Two slides. Then I can see what else I've got up here, if I want to burn some more time or not. All right, so the pass keyword. Okay, so it's a new word. I'm including it only because sometimes I use it. Okay, and you'll see me use it a few times. Basically, the word pass does nothing. So does the word none. It ends up happening. All right, you see, sometimes I write functions like this. Okay, let's write a function to calculate the GPA. Calculate GPA, and I'm going to pass in a student ID. All right, so here we go. How do we calculate it? I have no idea. Let me leave it blank because I've got other things. Print student, and I'm going to give some kind of a student ID. I'll just print X, and I'll just say printing student. Student details. All right, down here, I'm going to say calculate GPA, and I'm going to pass in some ID number. I'm going to get back a GPA, and then I'm going to print the student, print student, call it. All right, if I try running this program, what do you think is going to happen? First of all, something looks a little suspicious, doesn't it? Yeah, what's the suspicious thing here? Yeah, the first function, it's missing something. Yeah, it doesn't have anything. It doesn't have a body.
Yeah.
All right. If you try running this one, it blows up and it says expected an indent after the function because, well, indented code is the body. So yes, we are missing this. All right, what do we put in here? Well, if I don't know how to calculate the student, sometimes I just put in a placeholder. It's called pass. Just do nothing. Okay, just do nothing. All right. It allows me to at least continue on with the rest of the program. Here you go. The rest of the program now runs. It's just a temporary placeholder. I see that there's an example in here in the slides. Take a look what they've done. The user entered the word, entered a score, and if the score was bigger than 60, they did nothing, because you can't have an empty line. You need to have a body for an if statement. I would not write it this way. I would say if the score is less than or equal to 60, you need to repeat the test. That's a better way. But sometimes you're just doing a quick little hack on something. It's very useful for this. And as I say, sometimes I will use it like this. It just kind of blocks everything out. I know I need a function. I'll get back to it later. All right. Generally, I don't put questions about this on the test, but you'll see me do it here. Just temporary placeholder. So if you ever see me do it, it just means, I'm going to fix it before we're finished. But this way it allows me a chance to actually continue. And I quite often use it with functions, saying, okay, I need a function to do this, I need a function to do this, I need a function to do this. I'll come back to it later. All right, the final thing, a docstring. Okay, so a docstring is simply a comment describing the function, what it does, what the parameters are, and other things. So here we go. Let's go and write a docstring. All right, help print. See, that's very nice because it tells me exactly what it does. Okay, that's fine. But what about a function that you write? Okay, so there you go. What does a function do?
Calculate that swing.
I was really nice. I left it as a comment.
Yeah.
All right. It says it estimates the width of a given string based on the font size and type. Oh, perfect. Really, I should have written a little bit more, but I didn't want to. I had to cut it down because I was trying to fit it within the slide without making the font really small. But I should go on and say that the font size is the size of the font. I should go on and say that the font type automatically defaults to Calibri unless it's passed in separately. And I would also have to say that the function returns this error in this case, it returns this error in this case, otherwise it returns the box in pixels. Okay, that's a description of what the function does. That's a comment. I know in infs1201 you learned about comments, because I remember teaching that course, and I asked a very simple question to the students there. I said, do you think professional programmers write comments all the time? And strangely enough, a bunch of people said, of course they do. And the real answer is, no, they don't. Why? The word was here, just where was it? Okay, the word's right there on that page. Why do programmers not write comments? There you go. Yeah. So if you think students are lazy, yes, real programmers are also just as lazy. I did once ask one of the programmers. I said, "Oh, come on, we got to put comments in here." And he said, "Yeah, but we've run across situations before where somebody wrote a comment, and then they changed the code, but they didn't update the comment, and now you had a comment saying it did one thing, but it really did something else." Well, that's a quality control issue.
Yeah.
All right, that really isn't. Let's not do it. However, comments for functions is really, really useful. How do you define a function for a comment? Pretty simple. Inside the function as the very first line, not the second line, not the third line, not the line just before, but as the very first line, you use a triple quote. Doesn't matter, single quotes, double quotes. And what this is, this becomes something called the doc string. Okay, it's going to be one of these things. We will push you on to do it. We'll say for every function, please write a doc string. We're pretty lax at doing it. As long as people remember to do it, it's fine. Can we use it for something? And the answer is sure. You see, if you have a big system and somebody says, hey, there's a function in here called content or calculate text width, it will actually show it for you. It actually becomes part of the help system because you've got the doc string. If you don't include the doc string and somebody says, please give me a list of all the functions inside a module, the best you can do is say, well, there's a function, I don't know what it does. And this is what it's for, okay? All right, so let's see, what else did I have in here? All right, so there you go. That's what so it's always a function, or sorry, it's a comment for a function. Okay, I don't make people write comments all over the code, but functions are really useful because these are the building blocks we put big programs together. So you want to write what it does, what parameters are, and what the returns are. It has to be a string. It's usually a multi-line string. And in fact, everybody calls the triple quotes, they call it a doc string. No, triple quotes means multi-line string. That's really what it is. A multi-line string, or a string in the very first line of the function, that's a doc string. All right, and of course the doc strings can be viewed using the built-in help function. Whew, okay, I'm surprised I made it through. Okay, look, I've got one thing. Just give me 2 seconds to check something, and then I can ask whether or not we want to do it or not. Okay, and if you say, no, we've had enough, it's completely fine. I do have one of my super fun Kahoots. You want to try it, yes or no? If I don't, I'll do it another time, but yeah, okay. And yeah, if you say, no, my brain is full, okay, you can go outside and empty it. Okay, all right, so yeah, we'll give it a shot then. So it's both function flow. I can't remember what's coming in here, but create an assignment. No. Host live, sorry. So this one I'll show obviously be about functions. All right, so in worst case, it'll take 10 minutes. Hopefully it's even a little bit less, so function flow. Usually I give 2 minutes per question, so let's hope for like 3 or 4 questions. Okay, so there you go. Go ahead and okay, no participant. Oh, thought I was gonna get the go. Yeah, we get more people at the beginning of the class, don't we? Okay, can we reach 20? Do we have 20? Yeah, we definitely have 20. 19. Okay, one more, and then I'm starting. Otherwise, we'll be here for a long time. Okay, 21. Okay, go quick. 5, 4, 3, 2, 1. Chill. All right. All right, function flow. So the usual thing is it will probably ask you what is the output of this piece of code. Good, 4 questions. Hopefully, I've given 2 minutes for each. I can't even remember what these things do anymore. Oh, good. Only 1 minute. Function flow. I don't think I've got anything for function scope. Yeah, let's see if I can put one together for next time. Okay, how'd we do? Okay, excellent. All right, for once, more people answered correctly. Okay, so obviously that was too easy.
Can I see the option from here?
Okay, maybe number 5. 5 was the surprise one. So a bunch of people went after the blue one, which is 12, 12, 3, and 4. Okay, so no, remember the trick is when you hit a return, you are finished.
Yeah.
Okay, so it would print the 1, but it will never get here to the 2.
Yeah.
Okay. Okay, next question. What is the output of this program? Oh, that's bad. It's got a lot of stuff. Okay, a bunch of people got trapped into number 7, or into the blue one, 4, 1, 2, 3, 5. Let's take a look and see. All right, the first part is pretty simple. There's absolutely no way that it's going to be either red or green. Sorry if you picked that. Because the very first thing that gets printed is a 4. Okay, so guaranteed it's number 4. All right, so number 4 comes out, and then we call bad, so that causes a number 1. So now we have a 4 and a 1. Unfortunately, both of those have that option. So a 4 and a 1, that returns, and then I call good, that prints a 2. So a 4, a 1, a 2. Of course it is, okay. A 4, a 1, a 2, and then I call the function up here with a 1. So a 4, a 2, a 1, a no, I'm confused which one we've got. A 4, a 1, a 2, and a 1. Okay, a 4, a 1, and a 2, and a 3. There you go. So, yeah, you can work it out this way just by elimination. All right, so, again, just following through. Okay, so, let's see, next. Well, that seems nice and easy. really gave me any time for it either. Okay, so a couple of people went for a 1 and a 4. Okay, so yeah, remember the very first line that happens is line number 5. You call desk. A has the value of 10. You then calculate 10 plus 1. That's 11. You return that. It gets put into B and you print it. It's 11. Okay, maybe you just hit the wrong button. That can happen. All right, so one more. Okay, then we will be done. I meant to put pictures of bees on this one because it's just filled with bees. Well, good. Okay, the more people who answered it correctly, there was more of them, but a lot of people went after, let's see, the number 101. Okay, so let's very quickly go through this one. All right, there are 2 B's in here, but we call the function a bunch of times. All right, there is a global B, and then there's a local B. Inside the function called 1, it's always a local B.
Yeah.
Okay, so whatever happens up there has nothing to do with anything. Now, what it returns might have an impact, but whatever happens inside there doesn't have any impact on the global one, and the one that gets printed is the global one. So B has the value 100. I then call 1, passing in B. Well, B comes up to here. Okay, that's the value 100. We calculate B as being 101, and we return the value number 5. So B now has the value 5. And on this line right here, B is now incremented from 5 as set equal to 6, and then we print 6. That's why. Okay, so be careful. It returned this. It was a trick because maybe I'm after people who have some problems reading letters that look like a 5 and a B. Okay, maybe that's why I picked this one. All right, but in any case, it was really just to make sure that, yes, we have global variables. Now, or local variables. If I'd stuck the word global B up here, now we've got ourselves a nightmare on our hands. Because then we don't know when we're changing B, are we changing the parameter B or the global B? It turns out to be the global B. It'd be really, really unpleasant. All right, so there we go. And next. Okay, so those ones aren't too bad. So note to self, I won't use anything like these on the midterm because they're too easy. Do this. Actually, I've got usually questions I want to make sure people have got. It's not about how well you do on these things. Okay, so congratulations, Am. You are the winner, which you don't really get very much. All right, see you guys next week. Next week, according to the syllabus, I believe that you should have lab number 2, which will be an evaluated lab. Okay, so this one will count. Programming. Okay, should have to do with loops and if statements, if I remember. I'll post something on the weekend to let you know.